Hello friends, so this is another lecture of wave and optics. So today we are going to discuss about superposition of n collinear harmonic oscillations having equal phase differences. Okay, so first let us consider n different oscillations, harmonic oscillations having equal phase differences. So before we start, please do subscribe to the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you. If you want to follow me on Insta, this is my Insta ID, OZHA Loikhajit LAKHYAJIT Oza Loikhajit 123. So this is my Insta ID. You can follow me on Insta. So now let's start. So suppose equations of n harmonic oscillations having the same amplitude and same angular frequency but having equal phase differences. So suppose let us take y1 a naught sine omega t, okay, then y2 is equal to a naught sine omega t. Now phase difference is let us suppose phi, and y3 a naught sine. Now this one is differed by again phi, that's why it's gonna be 2 phi. So that means the phase difference between any two consecutive oscillations, harmonic oscillations, be phi. Okay, we have considered that way. And so yn is equal to a naught sine omega t plus n phi, sorry, not n phi. So when we have here y1, so it is plus 0 into phi, right? When we have 2 here, this is 1 into phi. So when we have 3 here, this is 2 into phi. So that's why when we write yn, then it must be n minus 1 into phi, right? N minus 1 into phi. So just give me a second. N minus 1 into phi. So this is the nth harmonic oscillation. Okay, so these are the equations. Now you see, if these are the n collinear harmonic oscillations, then the resultant will be obtained by equation of the resultant of n collinear harmonic oscillation that will be given by y is equal to a naught sine omega t, right? A naught sine omega t, then plus next one is a naught sine omega t plus phi, a naught sine omega t plus phi. Next one is a naught sine omega t plus 2 phi, a naught sine omega t plus 2 phi, plus dot 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 plus, and the last one is yn, which is equal to nothing but a naught sine omega t plus n minus 1 phi. That means we can say that the resultant is obtained by adding y1 plus y2 plus dot 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 plus yn, right? That's how we have got. Okay, so now let me copy this last step and let me go to a new slide, okay, as we have not enough space here. Sorry, just let me copy this last step. Okay, so here is the last step we have got. Okay, now you see, let us consider the resultant resultant wave, a resultant oscillation be like this. Before that, let me expand this using sin A plus B formula. Okay, so now you see, if we expand this result, sin omega t plus, now if you apply here sin A plus B formula, then what you're gonna have? You're gonna have a naught sin omega t cos phi plus a naught cos omega t sin phi. Similarly, you're gonna have from here, you're gonna have a naught sin omega t then cos 2 phi, then plus a naught cos omega t sin 2 phi, right? Then similarly a naught sin omega t cos 3 phi, then a naught cos omega t sin 3 phi, plus dot 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 and so on, and at the end you're gonna have a naught sin omega t cos n minus 1 phi plus a naught cos omega t sin n minus 1 phi. That's what we're gonna have. Now we can take a naught common, right? We can take a naught common from each term, and here you see from these terms we can take sin omega t, and from here also we can take sin omega t common, and here also we can take sin omega t common. Then from here also we can take sin omega t common, and if you do so, then what you're gonna have, a naught sin omega t is taken common from where it is possible. Okay, so take that, then you're gonna have 1, then from here you're gonna have cos phi, then cos 2 phi, then plus cos 3 phi, plus dot 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 dot, then cos n minus 1 phi. That's what we're gonna have. Now you see, from the remaining terms from here we're gonna take cos omega t, right, common, a naught cos omega t common, here also a naught cos omega t, so then what we're gonna have, plus a naught cos omega t, so we're gonna get sin phi plus sin 2 phi, right, plus sin 3 phi, and so on, and at the end we're gonna get sin n minus 1 phi. That's what we're gonna have. Okay, so now this is the resultant. Okay, so now if we consider, let us consider the resultant equation of the resultant oscillation. So equation, just wait, let us suppose, suppose the resultant equation of the equation of the resultant oscillation. The resultant B, suppose y is equal to A, this is the resultant amplitude, suppose sine omega t, and epoch or phase of the initial phase of the resultant B, suppose let me take it as a alpha. Okay, so amplitude of the resultant, or you can say simply resultant amplitude. Just you may write resultant amplitude here. Let me write here resultant amplitude. Just do it. Okay, so here you see, so here A naught is the amplitude of the individual harmonic oscillations. So here I forgot to give it I. Okay, so and is the epoch of the resultant. The resultant. Okay, so if you consider, now let me copy this last two steps and let me copy this is from here to this step, and let me go to a new slide. Okay, so then you see okay, so this, so here you see, now if we expand this resultant y is equal to, then we're going to have a sine omega t cos alpha plus a cos omega t sine alpha. So now here you see, if we compare this one, this is equation 1 suppose, and this is equation number 2. So comparing 1 and 2, comparing 1 and 2, because you see this is also the resultant, okay, and this is also resultant that we have considered. Okay, so now if you compare 1 and 2, then what you can see here, you see this cos phi can be taken as sum of this. Okay, and a naught sine omega t into this can be compared with this, and a naught cos omega t into this series can be compared with this, right? So that's why what we can write that cos phi is equal to cos alpha is equal to, we can write this, right? 1 plus cos phi plus cos 2 phi plus cos 3 phi and plus dot 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 so on cos n minus 1 into phi. That's what we're going to have. Similarly, we can write sine alpha is equal to sine phi plus or you can write 0 plus sine phi if you want to write. Okay, then sine 2 phi, then plus dot 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 sine n minus 1 phi. That's what we can write. Okay, now you see, we know that e to the power I phi, there is a formula that can be written in this way, complex form, cos phi plus I sine phi, sorry, not phi, alpha. Okay, so we can write this way. This is a complex number. So now you see, here you can see that this is the real part and this is the imaginary part, right? So you can say that this is the real part of this complex number, and you can compare this one with the imaginary part. This is the real part and this is the imaginary part of the real number, complex number. You can consider that way, right? So now you see, so here you see, if we compare this, just let me write this way, comparing this results with this equation, right? With this complex number, then what we can say, so let me copy this and let me go to a new slide. Okay, let me go to a new slide. Okay, so here you see. Okay, so we can write that this 1 plus cos phi plus cos 2 phi plus dot 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 plus cos n minus 1 phi is the real part of e to the power I alpha, right? Then sin phi plus sin 2 phi plus dot 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 plus sin n minus 1 phi is the imaginary part of e to the power I alpha, right? Now this e to the power I alpha, it can be written this way, that so that we can write this way, e to the power I phi plus e to the power I 2 phi plus e to the power I 3 phi plus dot 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 e to the power n minus 1 into phi. Okay, and this is equal to cos phi plus I sin phi, right? Then this is gonna be equal to cos 2 phi plus I sin 2 phi and so on, right? So that's why this part is nothing but real part of this. So if you ignore this plus sign, okay. Actually when you write this I alpha is equal to sum of this, then don't consider this one here, okay? Only take the terms of cos, okay? Then later on we're gonna add 1. Okay. So now you see, so that's why what we can do here. So what will be the sum of this series? Now this series in GP, if you see it, e to the power I phi, you can consider this one as 1, e to the power I phi to the power 2, e to the power I phi to the power 3 plus dot 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 so on, then e to the power I phi to the power n minus 1. Okay, and here the first term of this GP is e to the power I phi, and the common ratio is also e to the power I phi, right? And we know that sum of a GP up to nth term, it is given by this formula, that a into r to the power n minus 1 by r minus 1, and here we have n minus 1 terms, so here we're gonna have 1 minus n minus n 1, right? So that's what we're gonna have. So now you see, if we put the value of a and r, then what we're gonna have, this sum is nothing but this one, right? So e to the power I alpha, that's going to be equal to, this part is going to be equal to, according to this formula, if you put the value of a and r, okay, then what you're going to have, e to the power I phi and e to the power I phi to the power n minus 1, then e to the power I phi minus 1. That's what you're going to have. So now let me copy this last step and let me go to the new slide. Okay, let me go to a new slide. So here is the result we have got. Okay, so now what we can do here, we're going to simplify this. Okay, so how to simplify this? First, you see, okay, e to the power I phi into, that is e to the power I phi whole to the power n minus 1, it can be written as, n minus 1 by 2 plus n minus 1 by 2, right? Then again it will be n minus 1, right? If you add these two, okay, n minus 1 by 2 minus 1, and then if you apply the laws of index, then it can be written as e to the power I phi whole to the power n minus 1 2 into e to the power I phi whole to the power n minus 1 by 2. That's what you can write. Okay, and instead of 1, what you can write, e to the power I phi, e to the power I phi whole to the power n minus 1 by 2 minus n minus 1 by 2, so that if this powers become 0, then it will be 1. Okay, and if that is the case, then you can write this one as e to the e to the power this and into e to the power I phi whole to the power minus n minus 1 by 2. You can write this way also, right? Just let me write it properly, e to the power I phi. Okay, that's what we can write, divided by e to the power I phi by 2. You can write again e to the power I phi by 2 minus 1. Instead of minus 1, you can write e to the power I phi by 2 into e to the minus e to the power I e to the power minus I phi by 2, so that you can if you multiply these two, it becomes 1. So instead of 1, we have written this. Okay, so hope you have understood this. So now what we can do here, we can take commons, right? From these two we can take this common, and from this two we can take this part common, and then e to the power I phi and e to the power I phi whole to the power, or you can write this way, whole to the power n minus 1 by 2 is taken common. Within bracket we're going to have e to the power I phi n minus 1 by 2 minus e to the power minus I phi into n minus 1 by 2. That's what we have got, and divided by, and e to the power I phi by 2 is taken common. Then within bracket we're going to have e to the power I phi by 2 minus e to the power minus I phi by 2. That's what we're going to have. Okay, now here we see, here you can see that we have a formula that we can apply this formula. Sine x can be written as e to the power ix minus e to the power minus ix divided by 2. And if we apply that, what we can write here, so in that case, just do one more thing. What you can do here, if you divide this one by this, then you're going to have here e to the power I phi divided by 2, right? So that's what we're going to have. And if you multiply this one and this one, if you multiply these two, then what you're going to have, and then we end up getting this result, e to the power I phi by 2 into e to the power I phi n minus 1 by 2. If you multiply these two terms, then it's going to be equal to, this is going to be equal to e to the power I phi plus e to the power I phi n minus 1, this whole thing divided by 2. And if you simplify this, then you're going to end up getting I phi n by 2, right? And here if you apply this formula, then you're going to have uh, you know sorry uh, according to this formula, e to the power ix minus e to the power minus ix, that's going to be equal to 2 sine x. So here x is nothing but this is the x here, so that's why we're going to have 2 into sine phi n minus 1 by 2. That's what we're going to have, right? So hope you have understood this. And similarly here also, if you apply the same formula, then you're going to have 2 sine phi by 2, and this two cancels, so we're going to end up getting this result, right? Okay, that's what we're going to have. And this can be written using again we can write that e to the power ix is equal to ix is equal to cos x plus I sin x, right? So if we apply this one here, then what we're gonna have, just wait, give me a second, just wait. So then we can write cos x plus, so instead of x we're gonna write phi n by 2, okay, plus I sin phi n by 2, right, into sin phi n minus 1 by 2 by sin phi by 2. That's what we're gonna have. So now if you check this carefully, then if you see, so let me copy this last step and let me go to a new slide. Okay, so now you can see this one into this one, that's gonna be the real part, okay, and this one into this one, that's gonna be the imaginary part. Okay, so imaginary part or real part of e to the power I alpha is equal to cos n phi by 2 into sin n minus 1 into phi by 2 divided by sin phi by 2, and the imaginary part, this one into this one, okay, and the imaginary part of e to the power I alpha sin n phi by 2, then we have got this. Just give me a second, just let me write it. Okay, this is what we're gonna have. Now you see, let me go back to the previous slides. So here you see the real part of this is this, right? So let me copy this and let me go back to this. Okay, so that's why what we can do, so here we can write that this series is equal to this one, right? Okay, and similarly imaginary part is this one. Here you see, this is the imaginary part of this. Okay, so now let me copy this series. Okay, just here we can write this is the imaginary part, right, which must be equal to this one, right? That's what we have got. Now let me copy these two results, this one and this one, and let me go to another slide. Sorry, just give me a second. This is one result, and now you see our motive is to obtain this. Just wait, we need to obtain this one. Just wait, a cos alpha. Okay, so this is cos alpha. So a cos alpha is nothing but a cos alpha is nothing but, here you see, just give me a second, just wait. So sorry, okay, if you want to find a cos alpha, then you have to add the this add those amplitude also, right? So we're gonna have a naught here, right? We're gonna have a naught here. Similarly, a sin alpha, here also we're gonna have a naught, right? We're gonna have a naught. So hope you understood this, what I'm trying to say. So because this is resultant amplitude, and you're gonna get it get this a cos alpha if you add the add a naught plus a naught cos alpha, a naught cos 2 alpha, and taking a naught common, we have got this, right? So hope you have understood this. So here you see we can write that a cos alpha is equal to a naught 1 plus cos alpha, 1 plus cos alpha. Just give me a second. Sorry, a naught 1 plus, we can write this, it is, just wait, we can write this, right? That's what we can have, and this part is equal to nothing but this one, right? So a naught 1 plus, and remaining part is equal to this. Just wait. Okay, this is what we have got. Now if you simplify this part, then what you're gonna have, if you take sine 2 alpha common, right? If you take sine 2 alpha common, then what you're gonna have within bracket sine, sorry, not sine 2 alpha, sine 5 by 2. If you take sine 5 by 2 LCM, then here you're gonna have sine 5 by 2, then plus cos n 5 by 2, then sine, you can expand this also. If you expand it, then you're gonna have sine n 5 by 2 cos 5 by 2 minus cos n 5 by 2 sine 5 by 2. That's what you're gonna have, right? Then again you can multiply this term. Okay, if you open this bracket, just wait, if you open this bracket, then you're gonna have square here. Okay, right? Hope you have understood what I have done. So what I have done here, I have multiplied this one with this and this, then just wait, then if you multiply this one with this, then you're gonna get this term. So just remove this bracket. Okay, this is what you're gonna have. Okay, and if you multiply here, this will be square. Okay, so hope you have understood this. So now you see what we can do here. We can take this term common, right? From these two terms we can take sine 5 by 2 common, and if you do that, then what you're gonna have, just let me show you what you're gonna have. Sorry, give me just a second. Okay, so then you're gonna have this, just give me a moment. Okay, so now let me take this common. Sine 5 by 2 is taken common, then we're gonna get here 1 and 1 minus cos square, this cos square n 5 by 2, and sine 5 by 2 is taken common, right? And this is gonna be equal to nothing but sine square n 5 by 2, and this term becomes sine square n 5 by 2. That's what we have got. Now what we can do here, you see sine n 5 by 2, from here also we can take sine n 5 by 2 common, right? So if you take this common, then if you take sine n 5 by 2 common, right, you can write this one here, then this square will be removed. Okay, so this is only sine n pi by 2, and just give me a second. Okay, so then what we can do here, this sine n pi by 2 is taken common now. Okay, so now here you can see this is cos A cos B, sin A sin B, that means cos A minus B form. So we can write A naught is equal to cos n phi by 2 minus phi by 2, and we can write this sin n phi by 2 also here. So let me write that one first. Sin n phi by 2 is taken first. Okay, n phi by 2. So here you see this can be written in this form also. If you take the phi by 2 common, right, you can write this way also, divided by sine phi by 2. That's what we have got. This is A cos alpha, right? Now let's find sine A alpha, A sine alpha. So here you see, so now in order to find A sine alpha, so we need here A naught. Okay, so now you see, okay, just give me a second. So let me copy this last series, sine alpha, sine 2 alpha. Okay, and just okay, let me give this one equation number 3. So here is the new slide. So in order to find the A sine alpha, here we need A naught and this A naught into this one, right? And this is nothing but equal to this one, so we can replace it by A sine alpha is equal to A naught. So let me copy this result. Here we go. This is what we have got. So this is suppose equation number 4. Now let me copy the equation number 3 here. Just let me bring this one here. This is equation number 3. Okay. Now squaring and adding these two equations. Okay, if you square and add these two equations, adding equation number 3 and 4, squaring and adding equation number 3 and 4, if you square, then what you're gonna have, this one will be squared, this one will be squared, here also, here also, here also, similarly here also, here also, this one will be also squared, this one. That's what we're gonna have. And from these two, if you take A square common, then within bracket you're gonna have within bracket you're gonna have A square sine square alpha plus cos square alpha, and that's gonna be equal to 1. So we can simply write A square, right? So on the other side, you can take A naught square common. A naught square is taken common. Then also you can take sine square and pi by 2 common. Sine square. So sine square. Sorry. Just give me a second. Okay, sine square n pi by 2 divided by, you can take sine square pi by 2 also common. Sine square pi by 2 is taken common. Then within bracket we're gonna have sine square n minus 1 pi by 2 plus cos square n minus 1 pi by 2. That's what we're gonna have within bracket, and this is again equal to 1. So that's why we end up getting this result, right? So hope you have understood this. Now remove the squares from here. Just wait. So this is what we have got now. So hope you have understood this. These things are clear to you. I hope so, right? So now you see. Just give me a second. Okay. Just a second. Okay. Sorry. Okay. One more. Just this is what we have got. So now you see, so what we have got here, this is the resultant amplitude. If you find A here, so remove the square sine n phi by 2 by sine phi by 2. That's what we have got, right? So this is the resultant amplitude. Okay, we have got. Now if you divide 4 by 3, okay, so let me copy these two equations, 4 and 3, and let me take a new slide. Here we go. This is a new slide. Okay, dividing equation number 4 by equation number 3, we can have a sine alpha divided by a cos alpha, and then if you divide these two gonna be cancelled. Okay, then what are the terms gonna be cancelled? These two also cancel. Okay, then a naught cancels. Then remaining terms, that's gonna be only sine n minus 1 phi by 2, then cos n minus 1 phi by 2. So now here you see, dividing equation number 4 and 3, we have got this result, and here a cancels, so we can write this simply sine alpha by cos alpha, that's going to be tan alpha. Here also we're going to have tan n minus 1 into phi by 2. So here alpha is equal to n minus 1 phi by 2. Now you see, if n tends to infinity, if n tends to infinity, that means if n is very large, then we can write then n minus 1 by 2 is very close to, is approximately equal to n by 2, and then we can write, therefore we can write this is the phase of the this is the phase of the initial phase of the resultant oscillation, that is epoch of the resultant oscillation, that can be n by 2 into phi. This is the epoch for the resultant oscillation. This is what of the resultant oscillation. And the previous one, here you see, this expression was the expression for resultant amplitude of resultant oscillation. So hope you have understood this. Thank you for watching. See you in the next video. Bye bye.